we can work as many as you guys would like. So we'll go ahead and just start with number 6. And all right. So number 6. 4, 2, 5. 3 divided by 2, 2. Base 6 numbers. All right. So to do the division, trying base 6, but we understand these are base 6 numbers and write it out traditional way. 4, 2, 5, 4. But before we can do the division, the problem is I don't know the products in base 6. So what I'm going to do is I'm going to construct a little table in here. And then put in the digits, all the digits of base 6, which will be 6 of them. 0, 1, 2, 3, 4, and 5. The next row is simply going to be each digit times 2 to base 6. So I'll know what all the products are of each digit multiplied by the divisor. So the first two forgiveness, they've got to be 0 and 2, 2. Times 1. So now 2, 2 times 2 will be 4, 4. When you multiply that out, you're not going to have to convert. So remember, the way we're going to multiply is we multiply each in base 6, and then, or excuse me, in base 10, and then convert as we go. So 2 times 2 is 4. And then convert it. So when I get to 3, I'll do 3 times 2 is 6. But 6 is 1 root 6 plus 1s. So it's 1, 0. Good. So 0 carry 1. That's going to be 3 times 2 is 6. Plus 1 is 7. 7 on base 6 would be 1 root of 6 plus 1, or it's 1, 1. So 1, 1, 0 would be your product. And 2 more to go. So 2, 2 times 4. So this would be 8. Now 8 and base 6 would be 1 root of 6 and 2 ones. So 2 and a 1. Then 4 times 2 is 8 plus 1 is 9. And 9 would be 1 root of 6 and 3 ones. So it's 1, 3, 2. And then one last one, 2, 2 times 5. So that will give me 10. 5 times 2, which in base 6 would be 1 root of 6 and 4 ones. And then 5 times 2 is 10, plus 1 is 11, which would be 1 root of 6 and 5 ones. 1, 5. Now, once I have this, I can consult the table and know how many times 2, 2 is going to go and down the line as we do the division. So when I look at it first, I'll say, well, this will go into 4, 2. Just 1 can't go 2 times because that's 4, 4. So I'll put 1 times 2, 2 is 2, 2, and then subtract. So 2, remember, we are subtracting in base 6. So 2 minus 2 is 0. 4 minus 2 is 2. Bring down the next digit, which would be a 5. And now, consulting back to the table, it's going to go 5 times. 2 times 5 is 1, 5, 4. So I can go all the way down the line, looking for the largest one I can get in here. This is smaller than 2 and 5. So 5 times 2, 2 is 1, 5, 4. subtract. Now, 5 minus 4 is 1, and here I'm going to have to borrow. So reduce that by 1, and then you're bringing over a group of 6. So 6 plus 0 is what? 6. 6 minus 5 is 1. Bring down the 4. And so this will have to go 3 times. 3 times 2 is 1, 1, 0. I'll subtract. That's just going to give me 4. All right, so then I bring down the next digit, which is 3. So this will only go once. Can't go twice. Then 4, 4. So minus 2, 2. And my remainder will be 2, 1, which is smaller than the divisor. And we are finished with the problem. Any questions on that? You good? Okay. What next? Another problem. Number 2. Okay. That was the base 16 addition problem. Okay. All right. So number 2. All right, I'm going off my memory here. A, B, C, D plus DF. Now this is base. For the addition, we shouldn't need a calculator. In multiplication, you probably want to use a calculator to do the conversions. But before you start, anytime you're working base 16, put together all the digits. That is 0 through 9, and then A, B, 16 digits. And the digits beyond 9 are in base 10. So, now, once I do that, so the process will be anytime we're adding in another base, we'll just add each sum in base 10 and convert to base 16 each step. So I'm going to be looking at D plus F, which would be 13 plus 15. So that's 28. And that is base 10. So now I'm going to convert to base 16. So it's a question of how many groups of 16 is going to be in 28. Well, it would be just what? 1. Now, that leaves me a remainder of 12. And then I go back to my chart here. And what is 12? It is what? C. So that's C. And so it's 1C. And so that means I write down the ones place, which was C. And I carry the first place, which was 1. And now I add here. So I'm going to have 1 plus 12 is 13, plus 13 is 26. And you can actually kind of use this. If it's 2, 6, then that's going to be one group of 16. And then this would have to reduce by 2. So it would have to be 8. And that would be, you know, one group of 16 plus 10 is 26. So it's 1A. So A, area 1. And then you're looking at 1 plus 11, which would be 12. So that's easy enough. That's got to be C. And then you just bring down the A plus 0. So that is it. Good. Okay, another problem. Yep. That's the one that always gets asked. It is multiplication, it's the same process no matter what base you're in. The base 16, working in base 16, definitely is a little more challenging. So. All right, and one of my memory again, I believe, is number 5, it's A, B, C, D times F. So this one, I would advise using a calculator. Simply, the products are going to be a little bit bigger. And so I mean, if you can do it mentally, that's awesome. If you're looking to get that good in your head, but I wouldn't torture yourself like that. So since multiplication is repeated addition, same process, but I'm going to multiply in base 10 each individual product, convert back to its base 16 as I go. So I'm looking at 15. If I'm going F times D, I'm going 15 times 13. So 15 times 13, 195. Over here, just do my conversions. So now this time, there's certainly going to be more than 1 group of 16 in there. So converting back to base 16, what I can do is 195 divided by 16. So I get 12.1875, but that says it goes 12 times. So that is what C. So that is C groups of 16. Now I want the remainder. So the remainder, I would just find by going 12 times 16, which gives me 192. So I divided into what 195, so that says the remainder is 3. Good. So it's C3. So I put a 3 and I carry over a C and proceed. So now I'm going to go 15 times 12 and then plus 12. So that C that I carried over. So 15 times 12 plus 12 is 192. Now, 192, then I can just use what I previously did. That's 195 to C3, and 192 has to be C groups of 16 and no ones. So it is C0. So 0, carry a C. Okay. And onward and forward. So now we're going to go to 15 times 11, which is B. 15 times 11 plus 12. 15 times 11 plus 12. That gives me 177. Converting it to base 16, I'll take 177 divided by 16. It goes 11 times. So that will be B. B group of 16. The remainder here would be 11 times 16, which is 176. So there's a remainder of 1. So it's B1. 1 carried B. All right, now, I think we can do this one. That's going to be 15. A is 10, so 15 times 10 is 150. Plus 11 would be 161. So, and then if you're dividing by 16, that would have to go what? It looks like what? 11 times. Thank you. 161 divided by 16 is 10 times, my bad. 160. Anyway. So if it goes 10 times, that's A. And then the remainder would be 1. So it is A1, and I've got my first row completed. Are we good there? All right, so we go to the second product. Now we're multiplying technically by E0. So that's the placeholder. Okay, so I'm going E times D. It's going to be 14 times 13. And 14 times 13, 182. All right, so 182 divided by 16 goes 11 times. E root of 16. 11 times 16 is 176, so that will give me a remainder of 6. So it's E6, so 6. Very good. So now E times C plus B. E is 14. C is 12. And then plus 11. So 14 times 12 plus 11 is 179. So 179, it's got to be B groups of 16. Come back up here, and it would have to be 2 more than this, so plus 3. So B3. So 3 and carry a B. All right. And now E times B plus B. So 14 times 11 plus 11. Which is 165. Now, so 165, we have to be A groups looking at 161. It's going to have to be A groups 16 and plus 4 more, or plus 5. A5. Almost through with this part. So A5, here in A. Now I'm looking at 14 times 10 is 140, plus 10 is what, 150. All right. And we'll finally get a quotient that won't be a letter. 150 divided by 16 is going to go 9 times. So 9 times 16. 9 times 16 is 144. So that gives me a remainder of 6. So it is 9/6. All right. Just when we think we should be finished, we're not. Now I got to add, and remember we are adding in base 16. So I'm going to go 3 plus 0 is 3. 0 plus 6 is 6. 1 plus 3 is 4. 1 plus 5 is 6. So I haven't had to do any conversion yet. Now that's going to be 10 plus 6. This is where folks sometimes get a little confused. You got to remember you are adding in base 10. So then converting base 16. So that would be 10 plus 6 is 16. Now 16 in base 16 is 1, 0. So it is a 0 and carry the 1. And then 1 plus 9 is 10. And 10 in base 16 is A. Now we got it. You guys good? We're good? Okay, another question. Incidentally, these are the 3 problems that I was asked yesterday. Right on par with the other class. Any more questions? All right, so I'm going to cut the same deal as I cut with the class If you want to rework the problems, I I will take them Monday. If you're good to go, and you want to turn them in today, that's fine. So you got Michael and Samuel, if I know, Samuel, you did turn problems in. If you want to resubmit number 6, you can do that, and I will take them up to class on Tuesday. Now, past Tuesday, I'm not going to take them yet. Past the deadline, I won't take them. So that's that. Any other questions? Or I launch off on something else? Sorry, David. Enthusiasm. It's towards the end of the week and it has been a long semester. How's your other classes going, guys? Good? Good. Good. All right. Well, new stuff for today. We're going to multiply. So we got that. Yeah, what we're going to do is look at some alternative ways of multiplying, maybe some alternative algorithms. So beyond the traditional way we learned way back then. So we're going to look at 3 ways. The first 2 I would not consider to be practical, but they're kind of cool looking, and at the same time we can use to talk about multiplication, which is repeated addition. So I was going to randomly pick some product here. 234 times 27. All right, so this certainly is something we can multiply by a traditional algorithm. When, this day and age, just pop it in a calculator, which is what I'm going to do. And 234 times 37 is 8,658. All right, 8,658. Now, so we're going to look at 3 ways to find this problem. So first way, what I want to do is I've got 2 factors here. Pick the larger one. Now you can pick the smaller one, but the process will take much longer if you do. So what I'm going to do is I'm going to write 1, and I'm going to write 234, and we're going to create 2 columns. And I'm going to have you guys help me with the arithmetic here. I'm going to go here and here on both these columns, and I'm going to continue to double. That is either add itself or multiply by 2. So this one's easy enough. Double 1, we get 2. 234, I think this would be what, 468 double. And I'm just going to continue this. So this is 4. All right, so what's this double times 2? I'm sorry?
936.
936. Double again, so I got 8 double here.
1872.
And double again, that's going to be 16, and double again.
3744.
Now, I'm going to have you add up some numbers. I'm going to have you add this number, this number, this number, and that number. Add those 4 numbers up. And you get 8,658. You're good. Oh, no. What could have went wrong here? It should have worked. Uh-oh. All right, let's go back and check here. That would be 468, correct?
Yeah.
Let's check this one.
That's also right. That one's also right. And that one's also right.
All right, something is amiss. I don't know what it is yet, but something is amiss. What is it? All right. I'm getting a suspicion I know where it is. It's not you. Yeah. It's me. Okay, right back to here. So you were getting 8,318. You didn't get that either?
No.
I have never had this happen before. I mean, ever. So what?
I was getting 6,000.
That, well, I don't have my glasses on. That's, okay, that's what I had. I just read it
Yes,
wrong.
6,000.
Okay, all right, so all's right with the world. 8,600, 6,318, correct? All right. Punching 234 times 27.
I get 6,000.
So I'm fairly confident that's what I got the first time. Again, I don't have my glasses and I wrote this down and that's obviously not right. So that's where the problem lies. Okay. It was me. 6,318. So I may have just punched the number in wrong right from the get-go and then wrote down the wrong product. Okay, so all is right with the world. I knew this was good. This was the problem. Okay, now that I've done that. And 234 times 27 is 6,318. And adding up these four numbers is 6,318. All right, so question now is, why did I pick these four and exclude that one? Make an observation. Yes.
Is it because the numbers on the left, or you take out up to 27?
That's it, exactly. So what he noticed was, if I go to this column, 1 plus 2 plus 8 plus 16 adds up to be the other what? The other factor. of the 7. And that's exactly how this works. You just keep doubling and till you what? Can have the combinations of these that add up to be the other factor. Then you take the corresponding numbers. It'll work every time. It's the same idea that what any counting number can be represented by a sum of powers of 2. These are all powers of what? 2. We're just doubling. Now, is it practical? No, I wouldn't want to, the kid was struggling with multiplication. I probably wouldn't show him this, but in terms of showing it once and how it works, it does get back to the idea of multiplication is defined as repeated addition. That is, this is one group of what? 234. That's 2 groups of 234. That's 8 groups of 234. That's 16 groups of what? 234. And so all together, the 4 of them make what? 27 groups of 234, which is multiplication by definition. Okay, this is known. This is just one of those words I just perpetually misspell. Egypt. Is it E-Y? Jukin? Someone Google it.
Egypt,
Yes.
E-G-Y.
See, I'm telling you, professionally, I always get this one wrong. E-G-Y?
E-G-Y.
T-E-I-A-N, right? This is, huh?
That's Egyptian.
Okay. This is the part I get these two backwards all the time. It's the Egyptian. It's called the Egyptian. All right. Acting that. Okay. So we're gonna do the same product now that I've got that correct in there. That is, we're gonna come up with 6,318 again, going to through 234 times 27. But this time, I'm not gonna put a 1, I'm gonna put a 27. And then I'm gonna put the 234 here. Now, and just kind of like this one, I always want to take the larger factor here and double it. I still want to do the same thing with the larger factor here and double it. Now here you can see why it would work if I put 27. But you would be doubling and you would have to double down here until you had a combination that added up to be what 234. So it's going to take a while longer. You can have these inverted and to do this process, it would just take longer. But I want the smaller number here on the left, larger factor on the right. What I'm going to do is I'm still going to double on the larger one. But this one I'm going to cut in half. And I'm going to ignore remainders. So it is divide by 2. So double here, which would be 468. Cut this in half. So that's going to go what? So what? 15 times, right? With a remainder of 1, but we ignore the remainder. And we're going to continue this until I get 1 down this on this column. All right, so double here, where it got here, so 6. Divide by 2, so that's going to go 6 and a remainder of 1. Going to double here, so 272. Cut this in half. It's going to go what? 3 times, no remaining. Double this. And cut this in half, it would be 1 and a remainder of 1. And done. You always know where you're going to end with this one. It's going to get 1. Now we already know from doing the Egyptian algorithm that I want to add, these are the 4 numbers that are going to be added up to give you that product. But it's not going to be a combination of this column to add up to be the other factors. So what in this column makes me decide to use these numbers and exclude that? So I'm going to look at these numbers and make an observation about, I picked these. How are these different from that? Keep it simple. Don't understand. Okay, well, this one had a remainder. And this one had a remainder. But some, or what? What are all these 3 numbers? And this is, we classify as something else. Even, and these are all what? That's it. So you go down with this method, you go down the column, take out all the odd entries, and exclude the even ones, and then pull right to here. But that's how it's done. And it'll always work. Now, I do not know the origins of this one. I always say I'm going to go through so we can figure out what it is. I can only assume that it was developed by some Russian peasants. This is known as the Russian method. So, it's the way it works is a little, actually, it's a little bit more complex. We're honestly, because we're dividing, we're either getting remainders of 0 or 1, and it's base in base 2 or binary. Okay. Last way. This last way I do consider practical, and I know for a fact it is taught in the public schools here in Boone County. You may have already seen this at some time or another. And what you do, I'm gonna bring my put it right here, make a box. Now, the way you design this box will be totally dependent upon the number of digits in each factor. So the first factor is 3 digits, the second one is 2. I write the 3 digit here, and I write the 2 digits here. You've seen this one before? Yeah.
This method confuses me.
Does it?
Ever since elementary school, I can never do it.
Okay. You will be able to now, I promise. There is a very distinct use for this. Then, do you have to be able to do this long play? Nope. We can do it, by our traditional algorithm. And this isn't some sort of new math. This has been around forever. We'll talk a little bit about that here in a minute. Now, in each of these, so if you had a 3-digit times a 3-digit, you would have yet a bigger box, so on and so forth. But each of these boxes put a diagonal, so that bottom left, upper right. Yeah. Now, the next step is just go through and find these products, really small products. And so it is hoped at this point that your students will be able to do some basic base 10 multiplication. Their times tables. We had that discussion last time. 2 times 4 is what? 8. Now, you have 2 entries, so put a placeholder, it's an insignificant digit. 0, then what? 8. And now just go down the line. 7 times 4 is 28. 2 times 3 is 6. 7 times 3 is 21. 2 times what? 2 is what? 4. And 7 times 2 is 14. Good so far? Exciting? I'm sorry, I'm just teasing you. All right. Now, so I wrote a name here. Here's the deal. Add. So, and think about your traditional way you multiply. We were going when we did base 16 multiplication. You add those columns, right? So we did all our multiplication. We didn't have to carry anything. That makes it kind of a little bit better. Now I add on these diagonals. Now, this is where you're going to carry. This is where the carry comes into place. So you put the 8 here. This one is 8 plus 2 plus 1. That's 11. So 1, carry 1. 1 plus 6 is 7. Plus 2 is 9. Plus 4 is 13. Carry 1. 1 plus 0 is 1. Plus 4 is 5. Plus 1 is what? Notice I get that insignificant digit from 0. So it's 6,300 and what? This is known as the lattice number. All right, now, what makes it practical and useful? It's not if, you will have students, some particularly young students, not even adults, because I probably deal with it. A good deal with adults, when they're starting to turn back. But you will have some young kids develop differently in terms of hand-eye coordination. And just their overall dexterity and so on and so forth. You're going to have students that are very bright that struggle to write on some math that looks like chicken scratch. They haven't quite got it together. You can't beat them up, because that just shape their confidence. And so by that traditional way we do things, what can happen is the kid is really has trouble with their handwriting. They're going to go in, they're not going to get things lined up. They're going to start adding wrong digits. You see where I'm going with this? What is the advantage of doing it this way? Everything is what? Lined up. It's forced to be lined up. That's the advantage. And so if the kid is really struggling with that algebra just because their handwriting is so bad, and that's a struggle. You want them to have some way to have some success without a calculator. This is the perfect vehicle for it. So, I still want to get them to be able to use the traditional algorithm, but this certainly will work just as well. And, I had a student, long time ago. But I'll never forget him. He was extremely bright. I had him Cal 1, Cal 2, and then Cal 3, and just burned it up. But of course, this was back in the before we had online platforms and whatnot. So tests were on paper, and then I would have to grade it. And I always graded paper tests, and I do grade them, not problem for problem, or not test to test, but page for page. That is, I grade all page 1, I grade all page 2s. That does a couple things when I do that. One, for the most part, I don't use test on grading. And 2, it keeps the partial credit accurate. I did that 1. But this student, I would always take his and just put it off to the side, because I knew it was going to take longer to get. And because he had terms. And it just wasn't what it was. So the work was always there, but I literally would have to set, and this was back when I had 2015 bid, so before I got old. Write down on up there and so on and so forth. I mean, I'd have to get magnifying glasses, figure, but it'd always be there. So you're gonna have students like that. And that one is a very practical method. But again, it was used back in the I know at least 1800s. I don't know if I can find it. Oh. All right, so we didn't cover this section. You don't know what analysis is? Page 10, charismatic device. But this. So you guys can see it too. I'm on page 162. Backwards. And what you can see is this is the lattice method we just discussed, and this thing showing a picture here, they're called Napier guns, and every student would have these. So they didn't have to write all this down, they would literally pull out these columns and then place them down and then add down the diagrams. Okay. There will be homework on that web covering these 3. I'm thinking it's like total 6 hours. So homework is pretty light. If you're a little bit behind, you've got a chance to catch up this weekend. It's a light assignment. I'm going to get in here while the video is processing. I'm going to go ahead and stop